Okay, everybody. Let's go ahead and take a look at the rule of 4. We did these in class, but in case you were absent or in case you missed something, let's go over these. So we're going to go over the 2 examples. First being, how old are the kids? So we're going to look at Ralph and his sister and try to figure out how old they are right now when these 2 clues are true. And we're going to look at the phone carrier problem and try to help our friend decide which phone carrier is the better option to choose. So the first thing we're going to do is go through clue number 1. So when Ralph's age is added to his sister's age, the result is 15 years. So remember, when we're looking at mathematics, right, we're looking at the rule of 4. So we're looking at what is the context of the problem, right? If there are any words to describe what's happening, how can we describe what's happening? Let's take a look at the graph, right? Can we physically see what the connections are, what's going on? Let's look at the equations, right? Maybe the equations will show us what patterns there are, and maybe sometimes we can solve easily with the equations instead of the other 2 methods. And then also tables, right? We want to take a look at tables and see if we can spot any patterns and make some identifications from these 4 different areas of mathematics. So if I know right now that Ralph's age and his sister's age are added together, the result is 15. So I can go ahead and make a table. So that's what I'm going to do. I'm going to go ahead and make a table for Ralph's age. I don't need to call him Ralph, so just Ralph and his sister. Sister doesn't get a name. I'm not quite sure why, but there's no love for her here. So we're just going to say Ralph and sister. Now, what do we know, right? We know that together, when I add their ages, I'm going to get 15. Meaning this, if Ralph is 10, then his sister's got to be 5. Because if I add them together, I'm going to get 15. Where conversely, we don't know. Maybe Ralph is 5 and his sister is 10, right? At this point, we don't know who's older. We have an idea maybe because of the contextual clues on our picture here, but we don't know from the clue itself. What else could be 2? Let's see, if Ralph is 8, then his sister's got to be 7. If Ralph is 3, then his sister is going to be 12. And we can do one more just for good measure. What could it be? 9 and 6 maybe? So 9 and 6 is 15. So now once we have a table, we can graph that information. So let's go ahead and plot these points, and it's going to be a little hard to see. Oh, maybe not. So let's go ahead and plot these points. So if Ralph is 10, so we're going to go ahead and call this Ralph's axis. So he's going to be my x-axis just because he has a name. And his sister we will call on the y-axis. So we're going to put that this is sister up here. So sister's going to go on the y-axis. So if Ralph is 10, then sister has to be 5. It's always weird to graph like this, but I want to make sure I do. On the other hand, if Ralph was 5, then sister's got to be 10. Right? If Ralph was 8, then she would be 7. Let's see, if he's 3, then she would be 12. And the last one we have is 9 and 6, so 9 and 6. And so you can see how easily that forms a line. We can use the ruler to make sure that they all do line up, and in fact they do. And we know that if, let's see, if sister is 0, if sister is 0, then Ralph's going to be 15. And just like the other way also, if Ralph is 15, then sister would be 0. Because together their ages add up to 15. Okay, so that's what we know right now. Can we write an equation that represents this? Well, sure. From the clue itself, right? When Ralph's age is added to his sister's age. So right away we could say, Well, if I add Ralph and sister, right, what do we get? Right? When Ralph's age is added to sister's age, the result is 15. Right? So 15 years old. Also, right, you can include this as x and y. If you're going to Desmos, right, this could also be x plus y equals 15. Desmos only recognizes x and y variables. If I was going to write the equation straight from the line itself, well, I would have a y-intercept of 15, and my slope is going down 1 over 1, down 1 over 1, down 1 over 1. So if I were to write this as y equals, right, then we would say y equals, I start at 15 and I'm subtracting 1 x value every time, right? Essentially, I'm going down 1 over 1, down 1 over 1. So my slope is negative 1. This is purely fine, right? This works. But just in case you want to think about it in terms of lines also, we can. All right, do we know how old the kids are? Well, we don't, because all we know is that together, right now, their ages add to 15. But we don't know how old they are. We don't know anything else, so we need another clue. So that's where this second hint comes in. The difference of Ralph's age and his sister's age is 6 years. So they are 6 years apart, meaning if he is 6, then she's just born. If he is 7, then she is 1. Right? If he is 8, then she is 2. So they are 6 years apart, right? If the difference, meaning if I subtract Ralph minus his sister, right, then I'm going to get 6. So let's go ahead and make a new table then for Ralph and sister. We'll put some values on here as well. Again, it's just, what do we know, right? Ralph minus sister is 6. So I already gave you 2. So if Ralph is 6, then she is 0. If he's 7, then she's 1, right? We don't have to keep going in order, but you can. But we could also say, well, if he's 10, then she must be 4, right? Because 10 minus 4 is 6. If he's 14, 14 minus what is going to be 6, right? So 14 minus 8, so she would be 8, is 6. Right? And before we even go to the graph, let's write the equation right now. What do we know is going on? Ralph minus sister's age is 6. Right? Don't we know that that's what's going on right now? The difference between their ages is 6 years. So Ralph we know is older. It told us that by saying the difference between Ralph and his sister, not his sister and Ralph. That would make a difference. So Ralph minus his sister is 6. So he's the older child. So now we've got some values that we can graph. We've got an equation. Let's go ahead and graph this thing. So we know that 6 is going to be at 0. 7's going to be at 1. 10's going to be at 4. 14's going to be at 8. 5, 6, 7, 8. And these also, if you look at them, line up to be a line. Right, so notice that. So that's a good line right there. So let's go ahead and put a line there. And this value is going to stay forever because if he's 30, right, she's going to be 24. You're always taking away 6. They are 6 years apart. So this line is going to go forever in that direction because they're always going to be 6 years apart. Can I write this line in y equals mx plus b form? Sure, if I go backwards, right, and I figure out what that y value is. Do we need to? Well, no, we have an equation in regards to Ralph and sister. We could also say, right, x minus y, equals 6, right? If I needed it in terms of x and y, I could just substitute the R and S for X and Y. So if I was plugging into Desmos, I would probably need these two equations, right? So now what do we know, right? We know that these two lines are intersecting at this point right here, right? And we can use Desmos like we did in class to verify what this point is, right? Which I showed you in class. I'm not going to do that now because I'm not very good at editing videos. As I'm sure you're aware, these are all one-take videos. But we're going to look at this point of intersection, which is going to be about 10.5, 4.5. So when we identify this point here, right, we know it's going to be 10.5 and 4.5. Well, what does that mean, right? So let's come down here and we'll say point of intersection is going to be 10.5, 4.5. Well, what does that mean for us, right? Well, that means that's where the two lines intersect. But what does that mean? Well, it means that this point is true for both clues, right? It means clue 1 and clue 2 both have this point in common, which means this is the age of each child right now, right? Well, which child's which? Well, remember, Ralph was our X value, so this is Ralph's age, right? And this was sister's age. Right? That's what that means. So X value was Ralph and sister is 4.5. So right now, if I want to know how old are these kids where both of these facts are true, then we would say Ralph is 10.5 and his sister is 4.5 years old. Right? Done. Right? So again, the reason this is my solution is because it is true for both clues. Right? When we add their ages, we get 15. When I subtract their ages, I get 6. This point is true for both equations. All right, so then we went to a different kind of problem, right? And we looked at the phone carrier problem. And the phone carrier problem is basically trying to help a friend out, right? Again, we've got words, tables, equations, sketching the graph. A little different this time. We're just going to sketch it. We're not going to exactly graph the actual line. And then on this one, the problem's written here on our page. So let's go ahead and take a look. Again, we did this in class. We talked about this in class, so if you were paying attention, if not, this is what we went over. So your friend is starting a business and needs to decide between long-distance phone carriers. One company, PPP, Frequent Phoner Plan, costs 20 cents for the first minute and 17 cents for each minute after that. A second company called Small Business Plan, we'll do theirs in red so it stands out like last time, costs 50 cents for the first minute and 11 cents for each additional minute. Help your friend make a decision. So we want to identify for our friend which is the better company to go with. So right now, what do we know? Well, we don't know much, right? We know basically how much each plan costs and all that, but we don't know much at all. What can I do? Well, I could make a table from here, right? But the first thing we want to do is actually identify what our variables are. So we're going to go ahead and say that X is what, right? So what am I graphing here? Well, think about what we know about slopes and what we know about y-intercepts, right? So what do we have? Cost is 20 cents for the first minute and 17 cents for each minute after that. Each minute after that is a pattern, isn't it? It means if I have 1 minute, it's 17. If I have 2 minutes, it's 2 times 17. If I have 3 minutes, it's 3 times 17. This is my slope. This is my rate of change. And the 20 cents is going to be the 20 cents that I get charged no matter what, right? So for each minute, right, each minute is going to be my x-axis. Because we don't know how much it's going to cost to make a phone call until I know how many minutes we've been on the phone, right? So one value is dependent on the other. And then we also know then that the y value is going to represent the total cost of the call, right? Because I can tell you how much per minute, I can tell you all that kind of stuff, but I can't tell you the total cost unless I know how many minutes we've had. So let's go ahead and make a table. So we're going to do for PPP, we're going to say X and Y. Right, so for how many minutes? Well, this is where it gets a little tricky, but back in the day, well, and I think to some degree now, right? If you use your phone and you call the phone and you dial the number and someone answers on the other end, they charge you. Now, you have not been on a phone the full minute, but that first minute is what they refer to as your 0 to 59 seconds, right? That will cost you 20 cents. As soon as I hit that 60-second mark, or basically that 1 minute mark, you've been on the phone 1 minute, and now they're charging you an additional minute. So like this is going to be basically that 1 minute mark to 2 minutes, really, right? So 1 to 2 minutes is going to cost you an additional 17 cents. So 20 plus 17 is going to be 37 cents. And if I hit that 2 minute mark and I go anywhere between that and 3 minutes, it's going to charge me an additional 17 cents, which is going to be 54. Right? And if I go to that 3 minute mark, right, anywhere between 3 and 4 minutes, it's going to be an additional 17 cents. So at this point, we're at 71 cents for the call. Right? We could keep going, but I think we're okay there. Okay, so it gets a little tricky because this is your 0 value. This is your 1, 2, 3, and so on, because it's that threshold that you hit. Okay. Okay, while we're here, let's go ahead and take a look at small business plan. So let's make a table for small business plan. Same thing. So for that first minute, right, how much is small business plan charging? So theirs costs 50 cents for the first minute. And then every minute after that, it's 11 cents each additional minute. So once I hit that 1 minute mark, they're adding 11 cents onto me. So that's going to be 61. If I hit that 2 minute mark, it's going to be 72. If I hit that 3 minute mark, it's going to be 83, and so on. So hopefully that made a little bit more sense. Okay. So now, right, let me zoom out just a bit. What's not letting me? There we go. All right, so now let's make some equations, right? So what do we know is true? And down here it asks us to define the variables, but we did that up here. So X was minutes, Y was the cost of the call. And we're not going to graph, we're just sketching it. So let's write equations first. For our frequent phoner plan, PPP, what do we know about what's happening, right? Well, we know it's going to charge me 20 cents no matter what, right? My initial value is going to be 20 cents, and it's adding 17 cents every minute, right? This is my slope, 17 cents every minute. Because if I'm on there 3 minutes, 3 times 17 plus the 20, right? If I'm on there 4 minutes, 4 times 17 plus the 20, and so on. Same is true for small business plan. I have to move down just a little bit, but the same idea is going to be true, right? The total cost of my call is going to be what? Well, they charge 50 cents right off the bat, but 11 cents for each additional minute. So my slope for this second one, my rate of change, is 11 cents. All right? All right, so we've got equations, we've got table, we've got words. We need to find the point of intersection. Where do these lines cross? So that's what we're going to do. We're going to make a sketch. And in class, we went to Desmos and did this, right? This is going to be minutes, and this was cost, right? So this frequent phoner plan started at 20 cents and went up, right? So there's my PPP. That's my frequent phoner plan. This is going to be my 20 cents, right? My small business plan started a little higher than that at 50 cents, right? And also increased, but increased at a lower rate, right? Because it's only 11 cents per minute. Right, so that's my sketch. Notice I'm not being accurate. There's no numbers other than the 20 and the 50 that we know, and so on. So when we put these in Desmos and we looked for where they cross, right, we see their point of intersection right here. And on Desmos, we could identify that that point was 5,105. Right, that's where they cross. So let's go ahead and look back up here for a moment, right? We've got 5,105. What's the point of intersection? 5,105. Well, what does this point represent in terms of the problem? So in context again, what is it that we know? Well, X was what? Minutes, right? So this was minutes. And my Y value was cost, right? So we know minutes and cost. So what do we know? 5 minutes cost us 105 cents. So for both companies though, why do I say for both companies? Right? For both companies, how do I know? This point is true for both the PPP and the SBP. This point is where they cross. It's true for both equations. So for both companies, right, 5 minutes costs 105 cents. Now don't get carried away. This was cents because this was 20 cents, right? 17 cents. This is all cents. So that's really just $1.05, right? So we could say it like that if we want. It costs $1.05. Okay, both companies. Now here's the whole gist of the problem, right? Which do I tell my friend to use? Hey friend, which one should I use? This is all dependent on how long of phone calls he's going to make. So if you look real close, right, which company is cheaper up until 5 minutes? Well, I'd rather have 20 cents and 21 cents and 22 and 23 and 40 or whatever, right? I would rather have PPE if I was going to be less than 5 minutes. Right? Because that is the cheaper company right there. After 5 minutes, which company is cheaper? Well, SBP is now cheaper. This is going to be more expensive, right? These have higher Y values, a higher cost. These are lower cost. I want to go with SBP if I'm going to be making phone calls that are longer than 5 minutes. So in order to answer this problem, right, the answer really depends on how long of the phone calls he's going to be making. So which plan should your friend choose, right? Well, it depends. So again, it depends, right? It depends on what? On the length of phone calls he needs. Right? So it's going to depend on the length of the phone call he needs. If he needs less than 5 minutes, right? If calls are less than 5 minutes, right? Go with PPP. If calls are more than 5 minutes, go with SBP. It's a little bit more pricey for short phone calls, but in the long run, it's going to be cheaper, right? And so this is, again, a contextual problem for systems of equations. Hope it made sense. Like, subscribe, ring that bell for notifications.